Myself, Dr. Prashant Kumar Boltun, Professor, Mechanical Engineering Department, GIS College of Engineering, Kollam. Subject topics: Advanced Welding Technology, ME 703A. Today is the 13th lecture. So, Plasma Arc Welding. Plasma arc welding is a solid state welding. Is an arc welding process similar to gas tungsten arc welding. The electric arc is formed between an electrode, which is usually but not always made of sintered tungsten, and the workpiece. Arc plasma is a temporary state of gas. The gas gets ionized after the passage of electricity current through it, and it becomes a conductor of electricity. Introduction. In ionized state, gas atoms breaks into electron and ions, and the system contains a mixture of ions, electrons, and highly excited atoms. The energy of the plasma jet and thus the temperature is dependent upon the electrical power employed to create an arc plasma. A typical value of temperature obtained in a plasma jet torch may be of the order of 50,000 degree Fahrenheit against about 10,000 degree Fahrenheit in ordinary electric welding arc. Introduction. Again, arc welding process that produce coalescence of metal by hitting them with a constricted arc between an electrode and the workpiece, that is transfer arc, or between the electrode and the water-cooled constricting nozzle non-transfer arc. Plasma, a gaseous mixture of positive ions, electrons, and neutral gas molecules. In this right side picture is the plasma arc welding, how the welding is performed. There is a sealing gas nozzle is there, and the center non-consumed tungsten electrode, and in the tube, in the nozzle, the one is passage is plasma gases is passes, and another passes water jacket is there, and by the side of the water jacket, sealing gases are there. Sealing DC power supply, electrode negative, workpiece positive, and this constricting water cooled nozzle, plasma arc is formed. If the current goes, then plasma arc is formed. Then gaseous plasma melt the metal pieces. Weld pool is there. So deep penetration weld can be done in plasma arc welding. High temperature than any other arc welding process. Definition and concept. Plasma arc welding is an arc welding process wherein coalescence is produced by the heat obtained from a constricted arc setup between a tungsten alloy, tungsten electrode, and the job transfer arc. The process employs two inert gases. One forms the arc plasma, and the second seals the arc plasma. That we have shown you the figure. The two constricted passages there. One is plasma gases arc process, another is arc plasma inert gases are there. Two inert gases. Filler metal may or may not be added. Pressure normally is not employed. Principle of operations. Plasma arc welding is a constricted arc process. The arc is constricted with the help of a water-cooled small diameter nozzle which squeezes the arc, increases its pressure and heat intensely and thus improve arc stability, arc shape and heat transfer characteristics. Plasma arc welding process can be divided into two basic types. One is non-transfer arc process, another is transfer arc process. Plasma arc welding, this is how the welding is performed. Directional travel of the uh, nozzle and the side of this is a nozzle and the coolant is this is coolant water jacket and the sealing gases both side two passages sealing gases and this is middle portion is tungsten electrode. This is the orifice constrict the arc. Plasma stream. This is plasma stream. Sealing gases. The sealing gases. Sealed metal, solidified metal. This is filler rod, and this is base material, and the central line is a tungsten electrode. A non-transfer arc process. The arc is formed between the electrode negative and the water-cooled constricting nozzle that is positive. The arc plasma comes out of the nozzle as a flame. The arc is dependent on the workpiece and the workpiece does not form a part of the electrical circuit. Just as an arc flame, as in atomic hydrogen welding, it can be moved from one place to another and can be better controlled. Non-transfer arc plasma processes comparatively less energy density as compared to a transfer arc plasma, and it is employed for welding and its application involving ceramics or metals plating, that is spraying. High density metal cooling can be produced by this process. B is a transfer arc process. The arc is formed between the electrode and the workpiece. Transfer arc processes highly energy density and plasma jet velocity. For this reason, it is employed to cut or melt metal. Beside carbon steels, this process can cut stainless steel and non-ferrous metal also, where oxyacetylene torch does not succeed. Because of the higher temperature, it can melt oxides forms. Transfer arc can also be used for welding at high arc travel speed. Since the density of the uh, plasma density is higher, so high arc travel speed is higher than normal TIG welding process or other process. Schematic diagram of plasma arc welding. This is a schematic diagram already shown to you. Plasma arc welding. This is inert gases and passages, and this is inert gases. This is inert gases and sealing gases also there. So this is a electrode, tungsten electrode, middle portion electrode, and constricted orifice is there. So arc is formed, filler rod, this is filler rod, uh, this is plasma jet, arc region, this is the arc is formed in plasma jet, this is a molten pool, this is molten pool. So this is a plasma arc welding process. Transfer and non-transfer arc welding process and difference between that. This is left side is a transfer arc welding process, plasma transfer. This is the electrode, and this is orifice gas, constricted nozzle, sealing gas nozzle. This is a plasma jet, and this is molten metal. This is the workpiece. So plasma jet length is higher than others, and this is constricted transfer welding. But in on the non-transfer arc welding, this is electrode, this is a orifice gas, and the constricted nozzle, and this gas nozzle, sealing gases also in this passage. So here the arc is formed. So arc passes and the workpiece melted. Here you say the penetration is not so deep. It was widen arc than transfer arc welding. Equipment used in this process are power supply, high frequency generator, and current limiting resistor, plasma torch, sealing gas, voltage control, current and gas decay control, and the fixture. Process description. Technique of workpiece cleaning and filler metal addition is similar to that of TIG welding, tungsten inert gas welding. Filler metal is added at the leading edge of the weld pool. Filler metal is not required in making root pass weld. It is used to make both keyhole and non-keyhole type of welding. Plasma arc welding. This is a figure, a comparison between TIG welding and versus plasma arc welding. In this process, left side is TIG welding, gas tungsten arc welding. This is a electrode, tungsten electrode, and the passage is sealing gases as passes. This is a nozzle, so arc plasma is there, so melting is in the workpiece. And the right side, this is the right side, this is a tungsten plasma arc, the electrode, orifice gases, sealing gases, and the sealing gas nozzle. This is sealing gas nozzle, and the arc length is, you can see the arc length is too high than TIG welding, arc plasma, and so since arc length is high, so depth of penetration is higher than other process. Deep penetration, here also electrode negative, workpiece positive. Direct current, positive electrode, negative electrode. This figure is called plasma arc length. So you can see the length of the arc, and this you can see the arc length of TIG welding, gas tungsten arc welding. This is a plasma arc. Advantages: stability of arc, uniform penetration, simplified fixture, rewelding of the root of the joint saved. It is possible to produce fully penetrated keyhole welds on pieces up to and about 6 mm thick with square part joint. Excellent weld quality. It can produce radiographic quality welds at high speeds. It can weld steel pieces up to about 1/2 inch thick square bar joint in single run with no filler metal addition. Disadvantages: infrared and ultraviolet radiations necessitate special protection devices. So it is required to take the precaution to avoid this, protect the ultraviolet and infrared radiations. Welders need earplug because of unpleasant, disturbing, and damaging noises. Most chances of electrical hazards are associated with this process. The process is limited to metal thickness of 25 millimeter and lower for butt joints, butt welds. The application in tube mill application, welding cryogenic, aerospace, and high temperature corrosion resistance alloy, welding steel rockets, motor cases. So this is the figure doing the arc welding, plasma arc welding. Thank you.